This is going to be in the recording. Catherine, can you close the door, please? Or just close it a bit so we can't hear it. Sorry. Alright, so what we're going to look into now is Chapter 8C of the notes. So I know that the notes kind of look a bit bland, but the good thing is they're all quite straightforward and easy to understand. For the most part, just requires a little bit of explaining. So what we're going to look at is simple interest, and you've seen this word before when it comes to recurrence relations. Okay, so simple interest and recurrence relations. Now, we looked at some of these words last lesson. Principal, remember, is the amount that you normally start with. It's associated mainly with V0, which is the beginning or the starting amount. So principal refers to the starting amount, and generally it's either a loan or an investment. Okay, so whenever you see the word this amount was invested or someone took out a loan, it's referring to the principal. Okay, and again, initial value, all similar. Principal, initial value, starting amount, similar things. An investment loan earns interest. Okay, so generally when you put a loan in or an investment, you get interest. Interest is basically extra money on top that you either pay or you gain. Okay, extra money that you pay or that you gain, and generally it accumulates. Depending on the investment, it could be every year you get interest or every month you get interest. Depends on the investment. And these are things that you'll learn when you actually go out there and buy a house or buy a car or get a loan. You have to pay interest. It says here the amount of interest is earned each year is constant. Okay, so when it comes to simple interest, it only applies to this statement. The amount that you earn, so the amount of interest you earn is constant. Only with simple interest. Constant meaning it's always the same amount. Doesn't increase, doesn't decrease. It's the same amount of interest each year. Alright, so we can use these recurrence relations to actually make a simple interest recurrence relation. Right here. So V0, remember, means the starting amount. P just means principal, or the initial, or the starting amount. And then remember what this means, Vn plus 1. So how do you get the next term? It's the current term plus whatever the common difference is. And to get the D, remember this. Okay, it's how you get the so if you've given a percentage like this, and it tells you this amount of interest rate is being charged on this loan or investment, you have to figure out what the difference is using this formula. And I've shown you this before. It's basically this one where you get percentage over 100 times V0. Okay, that's what that is. You've written this in the second page of your notes, I think. Just a note, Vn just means how much money there is after a certain number of years. Okay, and Vn minus 0. So this tells you, what this formula does is it gives you how much interest is earned. Or amount of interest. Yeah, amount of interest earned. So if it asks you how much interest do you have to pay, or how much interest have you earned at this point, use this formula. So the current amount that you have, take away how much you started off with. So let's say, for example, I went to the bank, invested $1,000, and then after a year, the value of it is now $1,500. How much interest did I gain? $500, because now I have an extra 500. So it's basically just the extra amount that I have on top. Okay, let's do some examples. So this example, actually, I think I skipped on a few things. Oh yeah, skipped on this page. Sorry, guys. So as if you look at the linear sort of graphs, remember linear, or when it comes to arithmetic, you'll notice that it's linear, so it's a straight line. Okay, and if that's increasing, and if it's going down, that means it's decreasing. Okay, and it's always a straight line. Oh, and notice as well, if it's growth, it's plus the common difference. If it's decay, it's minus the common difference. Okay, let's keep going. Alright, so let's do an example of this. Alice invests some money into a fund that earns simple interest each year. The balance of the investment after n years can be modeled with the following recurrence relation. So here's our recurrence relation. and some important information we're going to use to actually figure out this question. It says here that V0, so the starting amount is 325, so that's my principal. And then here equals Vn plus 9.75. So what this is saying is that each year she's earning $9.75 in interest. So this is the common difference. Show using a recursion that the balance of the investment after 2 years is 344.50. Okay, so we've got to show them recursively, basically, that the amount after 2 years, so keyword there is 2 years, so that means the second year or the second term is this amount, 344.5. So we're going to do that. First part, so copy me as we go. Part A, you've got V0 equals 325. Okay, let's start with that. V1, so the first year, looking at the recurrence relation, you can see it's the current term plus 9.75, so it's going to be V0 plus 9.75. Oops, 9.75. So that means V1 will be equal to 325 plus 9.75. And that will be equal to 334.75. Okay, that's the first year. Second year, so V2, and I won't have to write every single thing. I'm just going to go V2 should be equal to. Actually, I'll write it because it's probably a good idea to be in detail always. So 9.75. So the V2 is going to be 334.75 plus 9.75, which equals 344.50. Okay, so that's how we do that part, showing it recursively that the amount after 2 years, so the second year, is 344.50. Okay, part B. Let's use another color. Part B. Find the interest at the end of the 5th year. So we need to figure out how much money did her investment make after the 5th year. So if we can see that V2 is there, V5, well, actually what I'll do is I'll use my calculator for this. Oh. Okay. I'll use my calculator for this one, so that we can actually see how it works out on my CAS. But basically, you can also do this as well on your normal calculators. Yeah, so if you actually have a calculator like this, you can do it there. But on my calculator, let's add a calculator. Oops. Okay. So on my calculator, all I'm going to do is use find out my amount after 5 years recursively. So if she started with $325, so 325, that's the initial amount. Right, let me just double check that it is 325, and it's adding $9.75, so plus $9.75 each time. So that means that's year 1, 2, 3, 4, 5. So on year 5, you've got 373.75. So V5, 373.75. Okay, now, so for this one, again, we're going to use this. Vn minus 0. So it's the total amount of interest after n years. So to work that out, all you're going to do is, I'm going to write interest earned is equal to Vn take away V0. And all I'm really doing is just, I'm getting the amount for V5 and I'm minusing it with how much I had initially to figure out how much extra do I have. Okay, so this would then be 373.75 take away V0, which is 325. And on my calculator, so just minus, so take away 325, and I made $48.75 in interest. Okay, interest earned. Okay, so she earned $48.75 in interest. Yes. What question? No, we're up to 8B. This is it's in the booklet. So I've taken out all the questions you don't need to do. Whatever's in there is the only ones you have to do. No worries. So C, at the end of which year is the investment going to be worth at least $400? So again, using your calculator for it. Part C, which year will we have $400? So I'm going to start again. So again, just to show you. So start off with your initial amount of 325. So there's your starting amount, and then you're adding $9.75 each year. So how many years will it take to get to at least 400? So there's year 1, 2, 3, 4, 5, 6, 7, 8. On the 8th year, they'll have $403. And I'm just going to put in brackets how much they have. $400. Okay, and then part D, show that the yearly interest rate for this investment is 3%. Now, this is something that we haven't really done too much of, but for part D, it's basically asking you, prove that the percentage for this amount, so that this amount is 3% of this. How do we prove that? Now, remember, this formula, this is what we use to find the D, but we're going to try and figure out what's the percentage rate. So to do that, I'm going to show you another formula. It's this. So percentage, if you want to figure out the percentage, it's going to be the amount divided by V0 times 100. Okay, and what that tells you is the percentage of the original amount. So initially, the question doesn't tell you what the percentage is. Okay, generally that's how it's going to be. So you just got to figure out now, working backwards, what is the actual percentage. It was 3%, but we need to prove it. So what I mean by this, amount divided by V0 times 100, looking at your recurrence relations, the amount I'm talking about is this. So maybe instead of amount, I might just use this instead, so it doesn't confuse people. I'm sorry if this is changing your thing. That should be D divided by V0 times by 100. That's probably a lot more clearer in hindsight. So if we do that, the percentage rate should be 9.75 divided by 325 times by 100. And that should give us 3 as an answer. So we go 9.75 divided by 325 times 100. And the answer is 3. Okay, so that gives us back to the percentage. Okay, so that's for that question. So use this rule to find original percentage. Okay, that's what we use that rule for, to find the original percentage. Make sense so far? Okay, cool. Let's move on. Another example here, and let's just blast through this one really quickly. So show using recursion the balance of the loan after 2 years. So I've got my recurrence relation. It's going to start at 720, and you're adding 39.60 per, I'm assuming per year. So this is going to be a loan that's charged. So that means Boris he's taken out a loan from the bank, and he needs to pay back the loan. Okay, so part A, let's do that. 720 is how much he began with. The next term, according to this recurrence relation, is adding 39.6. So it's going to be V0 plus 39.60. Therefore, V1 is 720 plus 39.60. That should be 759.60. Okay, done. V2 should be V1 plus 39.60. So V2 must be 759.60 plus 39.60. And V2 must therefore be 79.90. 9.20. Okay, easy. Part B, find the total amount of interest after 4 years. So this is after 4 years, so V4. So using your calculator again. Okay, calculator started with 720, so let's start with that. And he's adding, each term is 39.60, so 39.60. So we're looking at the fourth term, so term 1, 2, 3, 4. So there's term 4, 878.4. Okay, part C, at the end of which year does Boris first owe at least $1,000? So part C, we're going to do the same thing. I won't repeat. Do you want me to repeat this again, or we get it? Okay, so we're up to term 4. Which year will he at least reach $1,000? So term 4, 5, 6, 7, 8. So year number 8, or term number 8. I'll write it as a sentence. On the 8th year, he will owe what was it again? 1036.8. Okay, so which year does he owe at least 1,000? On the 8th year. And then part D, show the yearly interest rate of this loan is 5.5. So again, using that rule that I showed you of the D over V times 100 to find a percentage. So the percentage is going to be 39.60 divided by 720 times 100, and it should equal 5.5. So let's double check that on my calculator. 39.6 divided by 720 times by 100 should be 5.5. Done. Easy. All right. I hope that's made sense so far. It's pretty straightforward. Let's keep going. So we're going to try and smash out all of this. There's a lot of notes, I've realized. There's heaps of notes. Okay. Whoa. Okay, so many examples. Let's just do it. I might just do one of each. Is that all right, guys? Yes. And then we can do the rest as an example as well later on. Okay. So writing your recurrence relations. Remember, your recurrence relations are going to be instructions on how to get the next term, yeah? So basically, it should look like this. V0 equals starting term. So you want to make sure you refer to, tell me what the starting term is. And then Vn plus 1 is equal to Vn. Now you got to watch out. If it's increasing, then it's plus D. If it's decreasing, then it's minus D. So just watch out for that, please. I believe these ones are going to be balance. Okay, I would say these ones are just going to, let's just leave them as plus for now. Okay, plus D. All right, so part A here. So all of your answers needs to look like this. So I'm only underlining the ones that you need to change. So what's the starting term? What's the common difference? Oh, and in order to find that common difference, so remember this D. To find that, remember it's just the amount, the percentage over 100 times V0 to find that D. Okay. All right, so let's do that. So for the first one, I'll just put it there. Number 1, Alice invests $500. I can already say there is your initial value or starting amount. So let's write that down. V0 equals $500. Okay, and how do you get the next term? Vn plus 1 equals Vn plus, okay, well, let's have a look at the question. Account earns 4% interest per annum. So that means we're going to have to find what that D is using that rule that I wrote there. So it's going to be 4 over 500 times, 4 over 100 times 500. Okay, so that'll be, I think it's 125, but let me just double check. I know it'll be less than that. 100 times 500. 20. Oh, my bad. Okay, so 20. That's it. Okay, there's my recurrence relation for that. Nice and easy. Okay, next one. B. Okay, borrows 650 for a loan that is charged 7.5% per annum. Write down a recurrence relation for this loan. Okay, so for that one, V0, I always start with that 650. Nice and easy. And Vn plus 1 is equal to Vn plus, and then let's work out what the common difference is. So it's going to be 7.5 over 100 times 650. So 7.5 over 100 times 650 equals 48.75. So we're adding $48.75 each time. Okay. Makes sense so far? I think those are pretty straightforward. Yep. Okay, let's keep going. What's up? Alright, next examples here. Flat rate depreciation using recurrence relations. This is basically the same thing as what we've been doing. It's just now it's depreciating. Okay, so instead of plus, it is minus. So let's just smash through this. Alright, so same examples, but now it's just minus. Sharer buys a car, depreciates a flat rate per year. The value of the car after n years can be modeled by the recurrence relation. Now, the only thing that's different here is that sometimes it'll ask you what's the value of the car, or what's the value of the investment after a set number of years. Okay, and you've got to make sure you understand the difference there. So already I can see there is my initial value and there is my common difference. All right, let's start with that. Show the recursion, the balance of the loan after 2 years. So let's do that. So C0 is equal to 32,000. So C1 is going to be C0 take away 4,000. Looking at the recurrence relation, yeah, it tells you there. So C1 should be equal to 32,000 take away the 4,000. So the value of C1 is 28,000. Okay, and then C2, so the second year, should be C1 take away 4,000. So C2 should technically be 28,000 take away 4,000, which will be 24,000. Cool. So you have to make sure you show the full working out for these questions, otherwise you will not be getting the full marks for it. You can't just tell me that the value after 2 years is this much. You have to show it. Part B, find the total amount of the car after 5 years. Okay, so what's the value of the car after 5 years? So working it out recursively, you know that the initial value is 32,000 and you're going to minus 4,000 each year. So what's the value after 5 years? There's year 1, year 2, year 3, 4, and 5. So 12,000. Okay, so that's the value of the car. Which car's value? Find the total amount. Yep. Now, reading the question properly, it's asking us the total amount by which the car's value has depreciated. Okay, so how much has it gone down by? So if the value of the 5th year is 12,000, how much did it go down by in value? So if you started at 32 and now you're at 12,000, how much did it decrease by? Anyone know? Decreased by 20,000. So I would, just to be safe, reading the question properly, I would actually write this down as well, because it is a little bit vague, like as in not 100% sure if it's asking for the 5th term or if it's asking how much did it go down by. I would say write both of these just to make sure that you're covering all bases. Okay, part C. Cheryl wants to sell her car when its value is still at least $5,000. What's the latest year during which she can sell? So she wants to sell it before it reaches 5,000. So what's the latest that that she can actually sell the car? So at the 5th year, we're already up to 12,000. So we can't go below that amount. So 6th year, 7th year. Okay, so that means on the 6th year, she has to sell it or else it'll go below 5,000. Yeah, so on the 6th year, yeah. And I'll write down how much she'll sell it for. So it'll be $8,000. So she has to sell it on the 6th year. I do find that a lot of the times with most of the students that do these questions, they're able to do the math, but they don't actually think about what the question's asking. Okay, you got to understand what the question's asking because then that'll help you figure out what you need to do. Okay, part D. Show that the yearly depreciation rate is 12.5%. All right, so part D, we're going to use the same formula that I showed you guys before. So to get the percentage, it's just going to be D over V times by 100. Okay, same rule as before. So show that the depreciation rate is 12.5%. So for that, it's going to be 4,000 divided by 32,000 times by 100. And if our calculations are correct, 4,000 divided by 32,000 multiplied by 100. If that occurs, just press Control Enter, people. 12.5. So the percentage rate is indeed 12.5. Okay. I'm going to skip this because it's more or less the same thing. Okay. Let's go to the next one. Okay. I'll just do one of these because, again, it is the same exact thing. It's just two examples. So writing a recurrence relation now for depreciating. So minusing. I'll keep in mind that the rule is just going to say it's going to be the same thing here. So it's going to be initial value. So tell me what's the initial value or the starting term. And then Vn plus 1 is equal to Vn. Take away the common difference. Okay. So these ones are just minus. And I'll only do one of them because they're both basically similar. A, write down the recurrence relation to model the car bought at 36,500 and depreciating at this rate. Okay. Also keep in mind to get this common difference, it's the same thing as the previous one. Okay, it's just going to be the percentage over 100 times V0. That's how we get that D. Okay, same thing. All right, so always start with the initial value. And I can see the initial value is 36,500. And then Vn plus 1 is equal to Vn minus. Now this is going to be minus. So let's find that the percentage of this amount. So it's going to be 10.75 divided by 100 times 36,500. Okay, so 10.75 divided by 100 multiplied by, what was it, 36,500. 36,500. That equals 3923.75. So that means it goes down by that much each year. So boys, get your notes out please and follow along. I won't do the other example because it's basically the same thing. Okay, same exact thing. Same exact thing. All right. Okay, this is the last one, and then you guys can start working. So this one here is a little bit trickier because you got a unit cost depreciation. Okay, depends basically on two factors. Okay, when you do this, so when you buy something, it doesn't always decrease by a certain amount depending on the value of the market, for example. Like say, for example, when you use a car, the value decreases based on how many kilometers you drive. Or when you use a printer, the value decreases based on how many pages you've printed. Okay, it doesn't actually decrease on a certain percentage. Or when you buy a washing machine, the value of it decreases based on how many washes you've used it for. Okay, so it's not necessarily a percentage, but based on how many times something's occurred. Okay, generally it is constant as well. Okay, so it's very similar to the previous questions. It's just that now you got to understand that the unit or the amount it depreciates or increases by depends on how many times a certain thing occurs. Like again, I said, if you have a car, the amount of kilometers determines how much it goes down by. Or if you bought a iPad, maybe the number of hours determines how much it will cost. Okay, so for example, Ella buys a motorbike and depreciates at a fixed amount of 1,000 kilometers per 1,000 kilometers. So every time Ella travels 1,000 kilometers, it's going to decrease by a certain amount. Okay, the value of the bike after every so thousand of kilometers can be modeled by the following recurrence relation. So this is the value of it at the beginning. Okay, and every 1,000 kilometers it decreases by $100. Okay, every 1,000 kilometers it goes down. So part A. Thank you, Catherine. Show by recursion that the motorbike after 2,000 kilometers is traveled is valued this much. So 2,000 kilometers. Have a think about this now. What term would that be? So remember, every 1,000 kilometers it depreciates by a certain amount. So that means every 1,000 kilometers is a term. 2,000 kilometers means you're looking at term number 2. Okay? Term number 2. So that means if we start off with that, M0 is equal to 17,500. No. No.
Water.
No. No. No.
Water.
No.
What? It's water.
So M1, so after the first term, it's going to be VM0. Take away, look at the recurrence relation, 1,700. 100, sorry. Okay, so M1 is equal to 17,500 minus 100. And that will equal 17,400. Okay, M2 is going to be M1, take away 100. So M2 is equal to 17,400, take away 100. M2 is 17,300. So after 2,000 kilometers, the value of the bike is now 17,300. Remember, every 1,000 kilometers it goes down by, it depreciates by $100. This is what it means by, what do you call it again? Depreciation of unit costs. Okay, part B. Okay, part B. Find the amount by which the motorbike has depreciated after 500 kilometers. So how much did it go down by after 500 kilometers? Now remember, for that, we're looking at the fifth term because every 1,000 is one term. So if it's 5,000, you're looking at the fifth term. So if you use your calculator, you're starting off at 17,500. Okay, and you're minusing 100 each time. So that's term 1, 2, 3, 4, 5. So the value after the fifth year is 17,500. Now, it's asking how much did it go down by? Oh, what am I doing? Sorry, wrong one. 1,700. My bad. So it's asking how much did it go down by after 5,000 kilometers. So it decreased by $500. So you need to state that. Or you could write depreciated by $500. That also works. Okay, part C. How far must the motorbike travel for its value to be no more than 16,500? So it has to be no more than that. Okay. So I don't have to repeat this, but remember that's term 1, 2, 3, 4, 5. Now we're asking here, when it says no more than 16,500, it has to be below 16,500. Okay, so below. Sorry.
So 1600.
Yes. So how far would the bike have traveled for it to be below?
11K.
Well, let's have a look.
I think.
So this is term number 5, 6. Oops. 6, 7, 8. What are we up to? 6, 5, 8, 9, 10. Okay. Shh. I would say 11. So it has to be no more than that amount. So that means we're looking at below. Actually, no more than that would mean that it's still at that amount. So it would be 10. So sorry?
You're saying below.
It says here, actually, yeah, I should get rid of that. The wording here is the tricky part, I think. So it has to be, can't be more than that. So that means at the 10th term, remember, every term is 1,000 kilometers. So how many kilometers did the car travel already? 10,000 kilometers. Okay, it must travel 10,000 kilometers. Okay, now part D is a little bit tricky. Question here is saying, show that the depreciation amount is 10 cents per kilometer. So in order to do that, you know that the depreciation rate is $100 per 1,000. Okay, shh. Now in order to get this, there's no hard and fast rule because it really depends on what kind of question you're working with. But to prove that it's 10 cents per kilometer, all you got to do is 100 to this divided by the number of kilometers. Okay, that's all. I think it depends on the question. It really changes depending on what they're asking you. And that should equal 0.1. So you have to really read the question for these because it can get a bit confusing at some points and what it's asking you to do. Okay, I might leave that one and I might just do this one and that's it. Right, thank you guys. I'll do this one and that'll be it, last one. So writing a recurrence relation for this. So here we need to write down a recurrence relation to model the motorbike. Remember, for your recurrence relation, you always start off with the starting term or the starting value or initial value, and then it's going to be Vn plus 1 equals. These ones are going to be depreciation, so Vn minus D. Okay, this one's pretty straightforward, but you just got to make sure you read it. So I can see the motorbike was bought for 15,000 and it depreciates at 120 for each 100 kilometers traveled. So as a recurrence relation for A, it's going to be V0 equals 15,000. Then Vn plus 1 should be Vn take away 120. Okay, as a recurrence relation. So it's pretty straightforward. But you got to make sure when you do a question like this, it'll ask, you have to make sure you understand this bit. So it depreciates at $120 for every 1,000 kilometers. So it's slightly different to your normal ones. Alright, I'm going to stop there now.